Bismillahirrahmanirrahim. Let's complete the exam view for chapter 6, work and energy. Question number 11. You slam on the brakes of your car in a panic and skid a certain distance on straight level road. If you had been traveling twice as fast, instead of 100 km per hour, imagine it is 200 km per hour. What distance would the car have skidded under the same condition? In the first case, the work done by brakes, W, exactly equal the change in kinetic energy, right? So final kinetic energy, that is equal 0 minus initial kinetic energy, right? This is equal if F1 S1 equal negative mv initial square. The negative sign means this is force in opposite direction, opposite to the motion, that's it. Imagine if you double the speed was twice. So instead of V initial here, you will write 2V initial square times negative half M equals. Take 2 out here. 2 square mean 4 times negative half MV initial square, right? The force is the same because he said under the same condition. So S2 here equal 4S1, right? 4S1 because this amount equal FS1. So S2 equal 4S1. Imagine if it is the same, 1 or 2 times S2 equals 4 F1 S1. So F1 goes with F1, so S2, the second distance, when you double the speed, equal 4 times the first distance. So it would have skidded 4 times farther. So take care, guys, when you are driving. Second problem, which requires more work, increasing a car's speed from 0 mile per hour to 30 mile per hour, or from 50 mile per hour to 60 mile per hour. Which one needs more work? You know work equals a change in kinetic energy, right? Let's describe the first case. F1 is 1 equal, imagine the mass of the car is 1 for both cars. So you cancel the mass. And imagine that instead of mile per hour, make it meter per second for all. So you are not doing the same work, but to make it easier. So change in kinetic energy, half, imagine the mass is 2, okay? For both 2 times a change in velocity here, V final square, 30 square, minus 0 square. And in the second case, F2 S2, this is W2 and this is W1, equals half the mass, it is the same 2, same car. And here 60 square minus 50 square. Let's calculate the work done in both cases. Here is 30 square means 900. Here is 60 square, so 3600 minus 50 square 250, it equals 1100 or 1100. So as you see, the second case require more work, right? So from 50 mile per hour to 60 mile per hour, it needs more work. As you see, we imagine the mass of the car 2 kilograms for both. We imagine these speeds in meter per second for both. Number 13. A stone is held at a height h above the ground. A second stone with 4 times the mass. So M2 equals 4 times M1 is held at the same height. The gravitational potential energy of the second stone compared to that of the first stone. For second stone, BE1 equal M1G H. H is the same and G is the same. PE2 equal the mass, second mass for M1 G the same H, right? So for this amount we call it PE1, right? So the gravitational potential energy for the second stone compared to that of the first 4 times. So where is 4 times as much? Right, guys? Let's move to the next, number 14. You and your friend who weighs the same as you, so your mass exactly equal your friend's mass, want to go to the top of the Eiffel Tower. Your friend takes the elevator straight up. You decide to walk up the spiral stairway, taking longer to do so. Compare the gravitational potential energy of you and your friend after you both reach the top. Your friend start here and take the elevator and reach this point. You took the spiral stairway and reach the same point. The vertical distance for you and your friend is the same, so the potential energy, it is the same as your friend, because you and your friend at same height relative to the ground. So let's see the choices. It is impossible to tell, wrong. It is impossible to tell, wrong. Your friend gravitational potential energy is greater, wrong. Both of you have the same amount of gravitational potential energy as the top. This is right, because same vertical distance. Number 15, the graph shows the magnitude F of the force exerted by spring as a function of the distance x the spring has been stretched. Imagine that you have a spring and you increase the force every time. By increasing the force, what happens for the extension will increase relatively, directly proportional, F equal kx. So the right graph will be letter B. Let's move to the next. A heavy dart and a light dart are launched horizontally on a frictionless table by identical ideal spring. So you have this like a spring, sorry guys, spring, and you have like an arrow. and it is compressed, so when the dart can move or the arrow can move, will go directly on x-axis, as he said here. Both springs were initially compressed by same amount, so same potential energy stored on the spring. Which of the following statement about these dots عن الأسهم دي أو الarrows are correct? There could be more than one correct choice. There could be more than one correct choice. Let's see the first one. The dots both have the same kinetic energy just as they move free of the spring. Sure. Why you said that? Because both springs have initially compressed by the same amount. Letter B. The lighter darts leaves the spring moving faster. Yes, same potential energy, so they move with the same kinetic energy, but the one that has more mass, less speed, and the one that has less speed, more have larger. The one that has more less mass has larger speed. So the lighter dart leaves the spring faster. The lighter one has more speed than the heavier one. Because kinetic energy equal half mv squared. So the one that has small mass has high speed. Letter C. The heavy dart has more initial elastic potential. No, we said both have the same potential energy because both springs were initially compressed the same amount. So this is wrong. D. Both darts move free of the spring with the same speed. No, the one that has less mass has more speed. Both darts have the same initial elastic potential energy. Yes, same initial elastic potential energy. Let's move to, here the right answer A, B, and E. Number 17. When you throw a pebble straight up with initial speed V, it reaches a maximum height H with no air resistance. So this V initial, this V final equals 0, maximum height. At what speed should you throw it up vertically so it will go twice as height? Twice as height. Put in your mind that V equal square root 2 GH for a free falling object, and we can use this rule here. So when the height is h, the velocity is v. He asked you, at what speed should you throw it up vertically so it will go twice as height? So here, instead of h, we can write 2h to get the speed. Put in your mind this 2 goes out means 4, right? Goes out means square root. Square root of 2 times square root 2 GH. It is the same as the one up. And this amount we call it V. So square root 2 V. So this is the right answer. Let's move to the next. When you drop a pebble from a height h, it reaches the ground with speed v. Here is v initial and v final. If there is no air resistance, when you drop, got it? Drop. So v initial equals 0. So v equals square root 2 gh. It reaches the ground with v. If there is no resistance, from what height should you drop it so it will reach the ground with twice speed? So when the speed is 2v, put in your mind 2g, we need instead of h 4h, right? Because try to apply it, 4 goes up with 2, and 2GH means 2V, that's what we need, twice the speed. So here H instead of H will be 4 times. So the right answer is here. Let's move to 19. When you drop a pebble from a height h, it reaches the ground with kinetic energy K. So the potential energy here, all potential energy here, it changes to kinetic energy just before touching the ground, if there is no resistance. From what height should you drop it so it will reach the ground with twice as much kinetic energy? So you need to make the potential energy twice. You know potential energy equal mgh. It is the same object, right? And same acceleration due to the gravity 9.8. So you need to double the height, make it 2h to get 2p, 2 potential energy, right? So when you double the height, you doubling the potential energy for the object before it falls. So when before reaching the ground, it will have the same potential energy, and the potential energy were doubled because you doubled the height at the beginning. So what is the answer? Doubling the height, 2h instead of h. Last one here, two objects, one of mass m and the other of mass 2m. The first mass m and the other m1 equal m, m2 equal 2m, are dropped from the top of the building. If there is no air resistance, when they hit the ground, you know the whole potential energy will change to kinetic energy. So here the kinetic energy, if the kinetic energy for the first object PE, the kinetic energy for the second object at the same height, 2 potential energy. So just before reaching the ground, the potential energy will change to kinetic energy, and this potential energy will change to double the kinetic energy, right? So both have the same kinetic energy? No, the heavier one will have double kinetic energy. The heavier one will have twice kinetic energy? Yes. The heavier one will have 4 times? No. The heavier one will have half kinetic? No. The heavier one will have 1/4? Wrong. So the right answer is B. The heavier one will have twice the kinetic energy, because you know whole potential energy change to kinetic energy, and the only factor that is changed, the mass. You know potential energy depends on mgh, so the mass doubled, and h is the same, so the total potential energy doubled. So when it reaches to the ground, it will have the same kinetic energy, and it will double from the beginning. That's enough for this video. كان معكم مستر إبراهيم سلطان، فيزيكس اند كيمستري تيتشر. ربي يوفقكم انتم واولادي.